to my YouTube channel where I talk about everything math. Today I'm talking about order of operations, and more importantly, we're going to look at some of those Facebook equations where everybody has a different answer. Their egos come out and we end up losing friends. Sometimes they can be worse than political sides and memes. Yes, you know the problems I'm talking about, the order of operation problems that people put up on Facebook. Here's one. It's very similar to one I saw recently. 16 divided by 2. In the parentheses, we have 3 plus 2. So 16 divided by 2 times the quantity of 3 plus 2. And we have to remember that we have to apply order of operations to these things. Let me take a side step and explain this, because I think a lot of our arguing has to do with the fact that we don't understand why order of operations is so important. We just memorized it and we don't understand the reasoning behind it. Well, here's why we have it. Exponents, radicals, multiplication, division, adding, and subtraction, they follow a pattern that we apply when we work out these problems. But parentheses are an organizational tool that we created. We created this organizational tool because there are situations in life where you want to say, I want this particular part of the equation done first. Okay, and that's the purpose of parentheses, is to tell us do this part first. So whenever we see a parentheses, it says to do it first. Now let me give some definition to that. There are two different types of parentheses we tend to see. One like the one we see here, where we actually have terms inside the parenthesis. Remember, terms are only things divided by adding, subtracting, or an equals. Multiplication and division do not make terms, okay? And I'll tell you some things that people who didn't understand what a term was, some of the things they would say in the comments of some of these that I've seen. Now, when I have this going on, this is something different. This is multiplication. All right, now let me tell you what's deceiving about this problem. What's deceiving is we don't have any terms in this problem. Okay, we don't have any terms. All it is multiplication and division. We can't count what's in that parenthesis, because when we have something in parenthesis, like I said, it says do me first, but it also collects it as one thing. So really, this is saying 16 divided by 2 times this unknown thing I haven't figured out yet, which we can clearly see is going to be 5, okay? So we have to keep that in mind too, all right? That is an unknown thing. One time I saw someone say, oh, you have to multiply the 2 times everything in the parentheses. They were applying the distributive property. The distributive property only works when, and this is in the rule of the distributive property. You all learned this in high school, but we don't retain everything we learned. This has to be an independent term, which means there needs to be adding or subtracting between the 16 and this to be able to distribute. It has to be its own independent term. This is essentially one term. We don't have more than one term, so we can't apply distributing. You can't say the 2 is times the 3 and the 2 is times the 2. That does not work, okay? Because this is one term. It has to be separated, okay? And that is just a pattern of math. That is just something we discovered in nature. That is not even something we made up. The only thing we made up here was the parentheses, okay? Was the organization behind the parentheses. All right, so that's the first error I usually see. All right, so let's go ahead and let's start to solve this. All right, so the first step is these parentheses. We already talked about it. 3 plus 2 is 5. We all know we do that parenthesis first. So let's go ahead and do it. I have to keep the parentheses around the 5, and that is because it also has another function, and that is to mean multiplication. Okay, so now I have 16 divided by 2 multiplied to 5. All right, so still only one term. I can't do distributing. Okay, I can't do any of that stuff. So what do I do next? Well, I do the next thing in my order of operations, and that's multiplication and division. Okay, so let's look at what we do when we get to multiplication and division. All right, so like I said, I've seen tons of these. I I've had people argue with me tons of times that I don't know math, and I'm like, you know, I'm a math teacher. This is a very divisive problem. A lot of people, and I've heard a lot of people say that it was taught to them, and whether or not that's true, I'm not slamming any teachers out there, but that it's been taught to them to do multiplication before division. Let me tell you why that doesn't make sense. Okay, that just doesn't make sense. I'm assuming I'm talking to a lot of adults, so I'm going to talk about a lot of kids' heads. Math works within dimensions, okay? Multiplication and division are both repetitive functions of adding and subtracting. If I have 2 times 3, I could also write that as 3 being added together 2 times, and I would get the same answer, because multiplication is just repetitive addition. That's all it is. Just like exponents, they're repetitive multiplication. If I have 3 times 3 times 3, guess what? That's 3 to the third power. Oh, I put a 2. 3 to the third power. I multiply that 3 times. Okay, it's just a quicker way of doing it. Okay, as we go up, we find a quicker and quicker and quicker way, or we're going to be spending days working out a math problem if we resulted everything down to addition and subtraction. Okay, so we had to have some quicker ways. This pattern in math merged in nature of multiplication being quicker than addition, exponents being quicker than multiplication. So we have this thing going on, but it's not only multiplication to addition. There are more rules because of integers. We start getting into the world of integers and the world of irrational numbers, but they're essentially, division is just repetitive subtraction. It's the same thing. Multiplication and division serve the same function, okay? They're both repetitive of adding and subtracting. They're also both opposites of one another. Any word problem that I can solve with multiplication, if I looked at it from another direction, I could solve it with division, because they're really the same function. They're just opposite ways of looking at the problem, okay? We see this a lot with addition and subtraction. You all know that if I say Abby is, let's say 4 feet tall, and she grew 6 inches, okay? All right, she grew 6 inches. How tall is she now? I could add these and get the answer that she's 4 foot 6 inches, okay? But I could also look at this as subtraction. I could say, well, she's whatever she is right now, okay? Subtract 6 inches would equal 4 feet. They're interchangeable. They're opposite operations. We understand it in adding and subtracting. Division and multiplication always seems to be the hitch, that we don't understand that they're opposite. I can write them for vice versa ways, okay? And I think that's why it's so hard to remember that one, but everyone understands when we get to adding and subtracting, oh yeah, I do that left to right. That they can memorize because they understand that connection. But with multiplication and division, we forget that connection, that they're actually essentially the same function. They're just opposite. They're just opposite of each other, okay? And that is why they're opposite operations in algebra. That's why adding and subtracting is opposite operations in algebra. You see how all of this is interconnected? That is why the rule is I multiply and divide as it comes from left to right. And that is the hardest part of these problems. When people get them wrong, it's because they don't go as it comes from left to right. They want to do the 2 times the 5 first. You can't do that. That's not how the rule works. We have to have some rules of organization, and the left to right is the one we picked. We all have to do it the same way. If we said apply multiplication and then division, the answer wouldn't always turn out the same each time. The pattern doesn't work always doing multiplication first, then division, because they're essentially the same operation. So we have to do it left to right. All right, I think I've explained that enough, so let's go ahead and do it. 16 divided by 2 is 8. Then I multiply it to the 5 and I get 40. Okay, these rules work. They work. If I always applied multiplication and then division, it would not be consistent. It wouldn't be a consistent pattern in nature where the answer always comes out the same way. This is how it stays consistent. All right, so let's change this up just slightly, okay? Now, let's make it 2 terms. So what I changed in the problem, I put in red, okay? So let me change my color on my pen. All right, so now we have 2 terms. We have this term and we have this term, okay? And I think in the last problem, this is what people think they're looking at, okay? They think they're looking at this. In this problem, I could distribute first. Let me show you. Put your hand over the 16 divided by 2. I'm just going to look at this 3 times the quantity of 3 plus 2. If I did what was in the parentheses first, and then I multiplied, I get 15. Now let's do it if I distribute. So 3 times 3 plus 3 times 2. Okay, so I distributed the 3 times the 3 and the 3 times the 2. I get 6 plus, oh no, this is a 9, I'm sorry. 9 plus 6. I'm a little dyslexic. Sometimes I do the wrong problem at the wrong time. And I get 15. I get 15 both times. So this is a situation where I could distribute and I would get the same answer. The rule is only true if when doing it both ways, you get the same answer. So the moral of that is you have to have it separated in a different term to be able to distribute. All right, so let me look at the whole thing as a whole now. Because it's now 2 terms, I can apply order of operations of the multiplication and division step within each term, okay? Let me explain that again. I can't resolve this guy until all the multiplication and division is done anyway. So I can apply order of operations within each term. Let me show you that visually. All right, so I could do the parentheses or I could distribute. Doesn't matter, it's going to give me the same answer. Okay, so I do that first and I'm left with division in one term and multiplication in the other term. All right, so like I said, I have multiplication over here and I have division over here. I could do this systematically, do the division, then do the multiplication. Let's see what happens when I do that. Okay, so 16, 2 goes into 16 8 times, and then write everything else down. The next thing that comes in line is 3 times the 5, so that's 15. Okay, now watch what happens. Let's go back to, I finished the parenthesis. So now I'm separated into 2 different terms. So now I can kind of do my multiplication first even, okay? Because I'm in 2 different terms now. So it doesn't really matter. I can't do that adding step till the end, so who cares, right? So I could do 3 times 5 first, then do my division of 6 divided by 6 divided by 2, which is 8. And I'm still down to the same step. Okay, so only when it's separated into 2 different terms can I mix up the order of multiplication and division instead of going left to right. And that is because we still get stuck to this step. They're separated. They're 2 different things right now. That is what a term is. It separates things. All right, so now let's look at the last step. So again, I do all of my things. Look what I'm going to do this time. I'm just going to do them both at the same time. 2 divided into 16 is 8. 3 times 5 is 15. And look, voila, I'm down to the last step. The last step is I just add and subtract left to right. That doesn't seem to be a problem for people. They can remember that it's just left to right, like I'm reading a book, do whichever one comes when it comes to adding and subtracting. All right, and I get 23. All right, let's look at another variation of this problem. So what happens when then I put exponents in it and I put r in parentheses, and I haven't told you anything about that until now because it's a pet peeve of mine. If I had my way, and I know people already make a G out of this, but that's not the majority of the way people are taught, so I never make it a G. I would also put an R in here. because people don't understand the connection of square roots or radicals and exponents. Okay, they're opposite operations, just like multiplication and division are opposite operations, just like adding and subtracting are opposite operations. The problem is as we climb up that ladder, adding and subtracting, no problem. We just have some difficulties with sign numbers with that. Multiplication, division as opposites, no problem, but now we just put in a problem when we try to divide by 0. And we still have the negative and positive issue that we had on the adding and subtracting step. Now we're 2 exponents and radicals, and there's even more difficulty with my opposite operation. Not a big deal though. They should be treated as opposite operations. We should add them into the order of operations train or rhyme or whatever, because they share the same connection as multiplication, division, and adding and subtracting. But I'll get off my soapbox and do this problem. First thing we do is we do that parentheses. Because it's a separate term, we could distribute if we want. The next thing in order of operations is our exponent. So now we gotta do that. So let's go ahead and look at that. I have different slides for different things. Let's go on to the next one. Now I have to do my exponent, which I skipped. I skipped that slide. But 3 squared, or 3 expanded, is just 3 3's in repetitive multiplication. So that would be 9 times 3, which is 27. Let me point something out. Sometimes people skip count, and you have to remember, I teach multiplication through skip counting a lot. But I teach them that the actual skip counting is the addition. The amount of times you skip count is your multiplication. And a lot of people forget that, okay? If you skip count, you're adding. It's the amount of times you skip count that you're multiplying, okay? So if I skip count, I would have went 3, and then the second one in the 3's is 6, and then 9. I would have said the answer of this is 9, and that would be bad. If I added it, it would be 9. But we're multiplying, okay? Remember that exponents are just repetitive multiplication. So the answer is actually 27. And that gives us a very interesting thing here to talk about, which I will in a minute. Okay, so here's the thing. I could have done it that way, or because this is in a different term, remember, when they're in different terms, they're different things. They're pulled apart into different groups until the very last step. So I can kind of do things out of order. I could have done this 15 first and the exponent at the same time because they're different terms. You can apply the highest order of operations within each term. Okay, that will shorten your math a little bit. Okay, now, so I know this is going to be 15, so I'm just going to write that in. Now I got to divide these two. This is going to be hard. The best way of doing it is just leave it as a fraction. Okay, and that is why I did this, to tell you a fraction bar happens to mean division. Okay, think about it. You're less than 1. You're something small, okay? That's division, okay? Except for when you're dividing a fraction into a whole number, which is a completely different video. Okay, and then I would have to, when I get down to this addition, you can pick either finding a common denominator, which is not too hard in this case. You would just have to multiply 27 to the 15, or you can turn it into a decimal. I'm going to turn it into a decimal since I haven't worked with any in this particular video. So that would be, I'm just going to round it to the hundredths place. And there's something I want to show you here. If I had divided this improperly and gotten a whole number, so if I had taken 27 divided by 16 in my calculator, I would have gotten 1.68, and that doesn't make sense, okay? 16 parts of 27 is less than 1, right? That's a fraction that's smaller than 1. Why would the decimal equivalent have a whole number? Why would it be 1.6878? I mean, that doesn't even make sense. I need a decimal that's less than 1, and that's what 0.59 is. And it makes sense because 16 is slightly over half of 27. Okay, so my decimal value should be more than that 50 cents, a little bit more than half a dollar. All right, last step is just to add them together. All right, and then you're done. Slides. Okay, so I hope this helped you get a little bit of fluency in your math, and I hope that it helped you for the next time you see one of those big math debates on Facebook that you can get the right answer to. If you like this, check out my other videos. You can also take my online classes. I have classes on outschool.com for kids under the age of 18 in high school or middle school. Mainly I have pre-algebra and algebra classes on there, a little bit of 5th and 6th grade math. Also, you can check me out on Udemy. That's where my test preps are. Right now, my biggest seller is my TEAS prep test. If you need help with the math portion of the TEAS test for entrance into nursing school, please check out my classes on Udemy. I also have other homeschooling math classes on Udemy, so go ahead and check those out as well. Also, check out our homeschoolmathmom.com. Coming soon will be our podcast on there. We break down how to assess different objectives in fun discovery type ways. So if you're a math teacher or you homeschool math, check that podcast out so you too can also teach pre-algebra in a discovery way. If you would like me to make a particular video on a certain topic in math, please put it in the comments below. I always love new ideas on math videos to make, and check out next week for our new math video. I try to put out one a week. All right, see you guys in the next video.